All right, our next talk is by Eric Masanet, who's a relatively new hire. Holds the Duncan and Suzanne Mellichamp Chair in Sustainability Science for Emerging Technologies at UCSB. And he works on developing energy material systems to identify technology and policy pathways for decarbonizing industrial systems. He used to be at the International Energy Agency, and before that he had a PhD in mechanical engineering from UC Berkeley. And he's one of the lead authors of the IPCC's sixth assessment report. So, Eric?
Thank you, John. Welcome. Thanks, everyone. Hope I get that afterwards. I realize I chose probably not the best title here because I don't have an answer for you about the future of data center energy use because it really depends on quite a few factors. So I'm an energy systems modeler and have been studying the IT sector and data centers in particular for about 15 years. And often I and my colleagues get asked this question: how sustainable is data center energy use? And with the rise of AI, it feels like we get this question pretty much every week from some reporter somewhere. And the answer which we typically give, which they don't always like, is it depends. It depends on one's perspective. So at the geographical scale, we know that data centers, especially in certain parts of the world, Chris showed a nice picture of a gigantic data center in Ireland. At a local level, they can provide really large point loads of electricity, which can stress the grid, lead to local water stress. So at the regional level, the local level, sometimes data center energy use can be a real problem. But if we zoom out to the global level, data centers, we think, comprise roughly 1% to 2% of global energy use. Is that too much? Is that too little? That's a tough question. It's about a third of the energy use of the global steel sector, maybe a sixth of the energy use of the global steel sector. So to really understand, what value we get as a society for that energy use, we really need to think about the services that come from data centers. So, it's really tricky stuff to figure out, the net benefits of digitalization. But there have been studies, and this is one coming from the IEA, looking at the potential benefits of teleworking instead of commuting to work every day. And it turns out, under the right circumstances, the fact that we have a data center and networks and end user devices allowing us to telework can save energy writ large under the right circumstances. So that's the second part of the question is, what are we thinking about? The net effects, the direct effects, and the answer can change. And the third part of the problem when answering this question comes down to just the frankly fairly poor state of data we have on this sector. So, you've all probably heard stories, scary stories about, data centers growing and gobbling up most of the world's energy. We're hearing that a bit about AI. And the fact of the matter is a lot of those studies use fairly simplistic methods because there's a vacuum of real data, a dearth of real data that are out there. So I've been studying the sector, in what I call the three eras of the data center. I just made that up on the fly. But in the first era, back when I started my career at Lawrence Berkeley Lab, we were asked to produce a study for Congress that showed the current energy use of data centers nationally and globally. We extended it to global. And in those days, the dot-com boom, when most of the world was getting wired up, data center energy use was rising rapidly. And then something really interesting happened around 2007, 2008, when data centers started getting really serious about efficiency. The cloud came into existence, virtualization, efficiency of servers improved, PUEs came down. And we think, I and co-authors think that, in that second era of data centers, which extended up until about 2018, there was not quite a plateau, but a very, a leveling off of data center energy use with very minimal growth for a lot of additional workloads. But if you just extend past trends, which is kind of tempting, right? The prediction was that data center energy use would really rise rapidly. And the thing about it is we don't really have great data for this sector. So, the range of estimates we dealt with in the last time we had rigorous global studies had about a factor of 4 difference. Part of the problem is companies aren't very transparent. Not many companies are reporting their data. So if we take a look at the range back then and the number of data center companies reporting, which my lab tracks, there's a huge gap between what we think the energy use is and the actual reported energy coming from some of the world's biggest players. And this is just a sneak peek at a dashboard some really ambitious students in my lab have been producing over the last year or so, drinking a lot of coffee, listening to a lot of music, scouring the net for data. And you can see, this is an industry that for a long time hasn't been very transparent about its data center energy reporting. So red means no reporting, kind of drag kicking and screaming into reporting. Green means companies are reporting, but for their whole organization, which tells you something about their data centers, but it's not their data center center energy use. And then there are some leading companies, I'll call out Meta, which is right here, which has been doing a great job for a long time. Can I get it? I can't get it. But they've been reporting data center energy use for quite a while, which gives analysts like me a good sense of how they're trending and what explains their growth. But we need a lot more of that. And the fact of the matter is, in the field of energy analysis, the challenge is getting harder, not easier, as the data center industry progresses. So I've been working on this schematic to just kind of relay the data complexities of what we have to track. And I apologize if it's a little rough, but we have IT capacity here, typical data center IT capacity. We can see data centers now up to almost a gigawatt, right? Not quite there yet, but we're getting there. And the efficiency of those data centers is on the y-axis. So it's tractable for us to track the big players, the cloud providers, the hyperscalers. There are probably hundreds, maybe a little bit over 1,000 of those facilities worldwide, and they typically tend to be very efficient, right? And then we move into co-location, wholesale market, and suddenly we've got tens of thousands of those data centers. Some of them can be fairly inefficient because they're multi-tenant properties, very little transparency on what's going on. And then suddenly we think about the data centers that are, privately owned. A data center is defined as something as small as like 2 racks even. There are tens of thousands, millions of those worldwide. And with the emergence of AI and pushing things to the edge, suddenly, we're dealing with understanding variations across millions and millions of point sources with very little transparency coming in terms of reporting, right? But from the indicators we are able to track, it's natural to think like that AI is going to be an energy problem because we see it happening at some of the big players, right? But from 2016 to 2022, we're seeing factor of 2, 3, 4, 5 growth in energy use among big companies that are reporting. The caveats there are that these are the big players for AI, right? They're not the only ones, clearly, but this is where a lot of activity is happening. And Google has been public about that the share of AI in their energy use has been pretty stable at like 10 to 20%. So this is not all AI either. It's a lot of AI, but and AI is growing at an absolute sense for Google. But this is only part of the system. And one of our challenges is tracking the efficiency of AI and other applications. So, we heard from Chris about the demands for just, the number of parameters and the compute required and the energy for AI models. But we also see trends from, Google, who is, they're making progress on the efficiency side. And they say that they're a factor of 83 more energy efficient and a factor of 700 more carbon efficient in their AR models. And just a week or two ago, IBM came out with North Pole. I haven't had the chance to really dig into this yet to understand it, but they're claiming a big breakthrough in AI efficiency. And we've got folks like William Wong and others at the Institute who are working on that problem space. So, where AI is going to play out is it's a tension between efficiency and demand. We know demand is growing. We know energy use is ticking up, but data centers are still around 2% of world energy use. And if they go a little higher for a lot of societal benefit, is that a problem? That's up to policymakers and consumers to decide. Colo market's going up, we know that. We see the trends there. The hardest part, though, about drawing conclusions about data centers overall is these are data from the US. The latest data we have are from 2012. Why 2012, you say? Well, it takes years for the EIA to compile data on commercial buildings, which is where data centers are located, to process those data and to release them. We just got the 2018 numbers and are processing them now. So, but half of the servers in the US, as of about 10 years ago, and we don't expect a big change in this, are in small data centers, which could be down to 2 servers per room, or mid-sized data centers. So that's a huge market, and they're generally inefficient, and they use a lot of energy. So it's tempting to draw conclusions about where data centers are going by looking at the big players and their trends. But in reality, we don't know where the whole system is going unless we can understand all data centers. And we think, at least in a decade or so ago, that a lot of these small data centers were shifting to the cloud and actually making data centers more efficient, not less. Okay, some more data here. The last thing I'll say is, in terms of the lack of data, we do understand how many servers are being shipped, but imagine trying to estimate the fuel use of cars in the US by only knowing how many cars were purchased each year. No clue on their energy efficiency, no clue on how fast they're retired, how many leave the stock each year. That's kind of the level that we're operating at. And when it comes to the edge, which is something we're watching really closely, and a lot of AI could be pushed to the edge, and it already is, a lot of small data centers, a lot of small locations, it's getting really tough, basically. The good news is that there are movements around the world to require greater transparency. So Europe actually passed this. I shouldn't call it a draft anymore because it's now in effect. This will require data centers operating in Europe above a certain energy threshold to report on key metrics like their energy use, their installed compute, I think, or the data traffic coming in and out. That's going to help, but just for Europe. We don't have anything like that in the US yet. There has been talk about it. It would be a great development. But there has been some movement to fund the development of KPIs and open data for data centers. And the next study, which is coming out of LBNL, this will be the third one that we produced at LBNL, should be coming out this year about the state of energy use in the United States. The good news is I think the industry is coming around and the research community is coming around to the need for better models, better data, more transparency. A couple of years ago through IEEE, we hosted a workshop on the state of data center energy modeling, and IEEE has agreed to give us space in a few months to host industry again to provide data into the National Data Center Energy Report, where we hope to address some of these data gaps, but we think it's getting a bit better. And really, I'll just close with saying, if we want to answer this question, if I had to give you an answer today, my guess is that a lot of the savings that helped us plateau in the 2010s, there's still some efficiency there, but demand is probably outpacing efficiency at this point. So we do think data center energy use is ticking up. We don't know by how much, but figuring that out is going to require more data, and it requires understanding where service demand is going on the one hand. AI is at the top, not by mistake. It's probably the biggest driver right now of demand out there, but also understanding efficiency progress and innovations, some coming out of this institute that can make make data transmissions more efficient. It's that tension that we need to pay attention to. And, but most likely when we complete our report for the US, I wouldn't be surprised if the number goes up, and globally if it goes up due to, this kind of imbalance that we have right now. But that's one of the reasons this institute exists, right, to help address this problem moving forward. So with that, I'll stop, and I hope you enjoyed kind of the big picture view from the energy analysis world.
Well done, Eric. Any questions for Eric? Yes.
Terrific talk. You can take a breath now.
Thank you. I tried to stay on time, which...
I'm curious about the economics here. How should we think about the question of whether the industry and society are underinvesting or overinvesting in efficiency?
Oh boy, I wish I had a good answer for you, David. So, the industry itself has made tremendous gains in efficiency. In fact, in a paper a few years ago, we calculated the annual efficiency gains of data centers at something like 20%, meaning like the amount of energy put in for the service that comes out is at about 20%. I think that blows away any other sector that we've ever seen, and it's partly due to the tremendous innovation that's out there. Whether or not we need more investments, I think we need more investments in, frankly, the data and knowledge infrastructure for understanding where AI is going and where societal demand for data is going. But there are lots of investments going in AI applications for this, digitalization of that. I just don't know if it's too much, too little. And kind of the role of what people like me do is we shine a light on the evidence that shows where it's headed and let others figure out if that's enough, too little, too much. Maybe someone else here could answer it during a break better than I could.
We had a workshop about a little before the one you mentioned, and we had Google and Facebook and everyone there, as well as a startup that had raised a lot of money, as well as PG&E and SCE. And the startup was talking about they're going to build this data center in San Francisco, and PG&E said you'll never ever build a data center in San Francisco. So it was a rather tense workshop.
Sure, it was maybe a tiny one, plan. But
yes, so.
Yeah.
Another yes.
Great talk. A couple of points. You did mention crypto and other sort of parts of the data center world that don't get a lot of attention.
Yeah.
Do consume a lot of power. And the second thing is I showed my globe of the network. We're building global computers, and the network power consumption actually gets not enough attention.
It doesn't. Yeah. Absolutely. So the network side, we think, and the IA's latest numbers show that it's on par with data center energy, is probably a bit larger. So that's another 1 to 2% of global electricity use. I need to be careful. Electricity use, not energy use, which includes all forms. And then you mentioned crypto. So we have studied crypto and produced some analyses and papers on that topic. In the US, it seems like when we speak about data centers, it's more traditional because crypto mining is almost all in dedicated crypto mining facilities. In other parts of the world, crypto compute often comes into hosted data centers and you know, what we would call traditional data centers. So that is a problem area, but we think it's about, you know, if the latest number for data centers is 300 to 400 terawatt hours of global electricity use, crypto is at about 100 or so, and that's nearly all Bitcoin, frankly. After the merge for Ethereum, that energy use dropped, and so it's almost all a Bitcoin problem presently. But it's a good point. Yeah.
So, how much percentage of all the planetary production of energy is used in these data centers?
Planetary production of energy?
Yeah, because
Yeah.
all this energy is like, you know, how many houses, cities, people could actually live on the energy being wasted?
It's a good question. I mean, we know the general scale, right?
I would just tax the shit
Yeah.
out of the electricity that you guys get
Ooh.
to improve your efficiency.
Yeah, yeah. Well, I mean, for the big players, electricity is a pretty high cost driver, so that explains a lot of the efficiency gains. But I mean, 200 to 400,000 is 1 to 2% of global electricity use. That's final energy, so like all the primary energy, the coal, the natural gas that went into that. I don't have the number. I could find it for you, but you know, it also depends on who claims what, right? Probably not in terms of primary energy. And then when you think of transportation energy use and building energy use, yeah, you can maybe double, triple it, right, David? Like
The growth that so it may, I think it's 4%, isn't it, sort of IT usage today, but it's growing very fast
Yeah.
is the concern.
yeah, yeah, parts of it, yeah. And you know what the range is? A lot of uncertainty there as well. Yeah, sorry. I don't know if I answered your question perfectly, but
I wanted to get a relative
yeah.
understanding how much, it seems like a lot of consumption of power, like you said, crypto. What's the point?
Yeah,
But there's more efficient ways to do this.
I would tend to agree. Yep.
All right.
You really think?
Okay.
All right,
Thanks,
we'll
everyone.
have to move on. So thank you very much, Eric.
Yeah, thank you.